All right, y'all. So I'm just mainly going to go over, like I said, chapter 7 quiz and then the information for the support for 8A. So some of y'all might have done this quiz already. I don't think it was actually due till the 18th, but I'm not sure. I think we're sort of back on schedule now. All right, so chapter 7 quiz, the first question. And it should be really close to y'all's questions. They might change a number up or two, okay? So the odds on your bet are 4 to 7. Remember, the odds are, that means against you. And I don't know if y'all have ever watched ESPN when they do these, they'll put these polls on there like odds to win the Super Bowl. Then you might see the first team 7 to 2, then 10 to 1. That's sort of what they're doing. If you bet on these Super Bowls teams to win it, then whatever you bet would be the odds against, okay? So your bets are 4 to 7. If you bet $28 and win, how much will you gain? And really what you got to do is set up those odds as a fraction, and then you're going to multiply by the $28 that you bet. So our odds are 4 to 7, so that means 4 to 7 is written as a fraction, okay? And then you multiply that by the money you're betting, which is $28. Now, if you want to, since you're multiplying this as a fraction, you could put a 1 under the 28 and multiply that thing straight across. So let me see what I get on that. Whoops, don't want the phone to do it, I want the calculator. So 4 times 28 on top gives you 112.
Oh, 157? 156.
Huh?
I thought you had to multiply both of them.
4 times 28?
28 times 7. Do you have to do that?
Oh, no, multiply straight across first.
Okay.
Now, I'll show you a different way that I can do something, but you might be talking about. And then let's see, 112 divided by 7 would give me $16. So what that means is, if you bet $28 and the odds are 4 to 7, you're going to win 16. So 16 plus the 28 that you originally bet would give you back, what, like $44 or so? Okay. Now, another way to work this. I'll still put a 1 under that 28 and make it look like a fraction. But I think what you're talking about is reducing the numbers.
That's what I was thinking about.
So the 28 and 7 would reduce by 7s each. So 7 goes into 7 one time, 7 goes into 28, 4. And then when you multiply that, you got what, 4 times 4, which will still give me my 16, okay? So $16. So then we would actually just type it in the blank as a 16, okay? And y'all should be close to that, 5 over 7 or something really close to them fractions. So y'all good on that one? Just remember, 4 to 7 right in as a fraction. Watch out, they might do 7 to 4, which would be a little bit different when you write it as a fraction, but still the same principle. Let's see how many different meals we can get from Pizza House. So Pizza House offers 5 different salads, 6 kinds of pizza, and 6 different desserts. I'm a little worried Pizza House only got 6 kinds of pizza, but they got 5 salads and 6 different desserts. They didn't have a lot more pizzas, wouldn't you? But we want to find out how many combinations of meals you can get. Like you want salad 1, hamburger pizza, pie. Salad 2, hamburger pizza, pie. So each one of them salads could go with either one of them pizzas and any one of them desserts. So this is one where you took all these numbers and multiplied. This was that multiplication principle, okay?
Okay.
So on this one, we just multiplied 5 times the 6 times the 6.
180.
So that'd be 180. So just using 5 salads, 6 different pizzas, and 6 different desserts, you got 180 combinations they can do out of that, okay? So Caesar salad, hamburger pizza, pie. Caesar salad, hamburger pizza, brownie. So you got, for those two, you can go 6 different desserts, and then you can say, okay, well, Caesar salad, pepperoni pizza with all them 6. So doing that, you would get 180 combinations, which is quite a bit, I would think, for that, right? Okay. And there's only 4 of these, so I'm on what, number 3? I mean, there was 6 of these, okay? On a multiple choice test, each question has 4 possible answers. If you make a random guess on the first question, what is the probability you are correct? So if you make a random guess, what is the probability that you are correct? And I ain't gonna lie, I've done this myself. I get to a question, oh damn, I don't know which answer this is. There's 4 choices, and if I pick one of them, I have a 1 out of 4 chance of being right. So you take the guesses out of how many choices were all together total, okay? So this stuff ain't that bad, is it? And what's funny is y'all do a lot of this every day. You just don't realize what you're doing every day with this stuff. Now, for some of y'all, it might not be pizzas and desserts. It might be, well, I got 6 different shirts, 5 different pairs of pants, 10 different pairs of shoes. How many different outfits could I make? Right? All right, y'all, let's see, number 4. So they're wanting to use a theoretical method. That's the one where you figure it out on your own to determine the probability of the outcome or event. So they're saying the next president of the United States was born on Tuesday. So they want to know the probability of the given event. So what you got to look at, they're looking at days you were born on, right? So you got a 1 out of how many?
How many presidents?
Well, no. So you're looking at, you don't care what number president it is, you're looking at what day he's born on.
So
So how many, whatever he's looking at the weeks. So how many days is in a week, basically? 7. So he's got a 1 out of 7 chance of being born on a Tuesday. He's got a 1 out of 7 chance of being born on a Wednesday, Thursday, Friday. So you look at all the days that are total for him to be born on, and then you look at that. Now, what if they just said, well, what's the chances of a president being born on Tuesday or Friday? 2 out of 7, because you got 2 days you're looking at out of the 7 total, okay? Okay, so the probability that Lewis will pass his statistics test so the probability that he's going to pass this test is 0.37. Find the probability that he will fail his test. And this sort of goes back to that P not A stuff. So the formula I'll use is the P not A equals 1 minus the P of A, which is the probability that it will happen. So they're saying his probability that he's going to pass is 0.37. So we come in and put 1 minus 0.37. So 37% chance he will pass, which means that's going to be 63. So that would give you 0.63, which means basically, if you move that decimal right, that's a 63% chance he's going to fail the test, okay? Y'all had going on, you also work about free throws. If his free throw average was 50%, what's his likelihood that he'll miss? Okay. All right, then we got the last one here. All right, so the last one on this quiz, a bag contains 6 red marbles, 3 blue marbles, 5 green marbles. What is the probability of getting a blue marble? So to figure out the probability of getting the blue marble, you need to count how many blue marbles there are. When they told me I had 3 blue marbles, so I can choose 3 blue marbles out of how many total marbles? Then you got what? 6 and 3 is what? 9?
9.
And 5? 9 plus 5 is 14?
Yeah.
So if you got 14 total marbles, 3 of them are blue, then you have a 3 out of 14 chance of getting a blue marble.
I have a question.
Uh-huh.
Why would you multiply it?
Oh, because we're not looking at how many combinations of marbles we can give. We're just looking at the chances of drawing certain marbles from all the marbles.
So that's right there.
Mhm.
Okay.
To where on that one you're thinking about where I had the pizzas and the salads,
Oh, yes.
we weren't looking at like drawing a salad or drawing a pizza. We just wanted to know on that one, how many possible combinations of the food could I get? Oh, hell, that's the end of that quiz, right? So if y'all ain't done your quiz, that's what your little quiz is over. It's not too bad. So now I'm just going to do a little bit, getting us ready for the 8A for next class by doing a little bit of the 8A support for today. Cool down my mask. Gets hot under these masks.
It's almost over.
So y'all, this will be 8A support. Now, some of y'all don't have to do support, so this will just be a few definitions for you to get ready for the big 8A, okay? So in 8A, we start looking at linear growth versus exponential growth. Coronavirus was exponential because it doubles by a certain percent every couple weeks, every couple months, or whatever. Linear growth is growth that goes up the same every year. So I'm going to write these down. And if you use a graph linear growth, it would look just like a line. That's what that linear means on this, okay? Okay, linear growth occurs when a quantity grows by the same absolute amount in each unit of time. So what they mean by the unit of time, it could be monthly, weekly, yearly, whatever you're looking at on your time frame. So linear growth, they'll say, hey, I bought a house for $500 and it increases by $10 a year. So every year it's just adding 10 to it, okay? So linear growth, same amount each period of time. Exponential growth. Occurs when a quantity grows by the same relative amount Now, what we mean by the same relative amount, we're meaning the same percentage in each unit of time. So let me explain the difference. Linear, it goes up by the same amount each year. So if it increased $10 in year one, it's going to increase $10 in year two, $10 in year three, so on. It's always going to increase by $10. Exponential increases by percentages. Something like, so if I I started with 500 and I increased by 10%, that means I'm not going up $10, I'm going up $5 out of the 50, which will put me at 55. The next year, I'm gonna go up 10% of 55 instead of 10% of the 50. So each year, you're getting more amounts, those percentages are gonna increase every year over time, okay? So you're not going up by the same amount, you're going up by the same percentage. So the key words, you see percentage in there, you know you're dealing with exponential. Exponential is the ones that can double over certain times. Y'all have heard them talk about doubling rate on this COVID, right? In the beginning, it took 2 months for it to double in cases. Then it started taking 1 month for it to double in cases. Then it started taking 1 to 2 to 3 weeks to double in cases. The doubling rate gets faster and faster on those exponentials, okay? And y'all seen them graphs shoot way up, didn't they? The United States was getting almost 200,000 cases a day. That thing was shooting way up there. Now we're sort of getting low in Arkansas, right? Less than 100 cases a day, I guess now. So exponential can fall sharply up or it can fall sharply down, okay? So I think I got what, I'll get just 4 little support questions and then I'll be done with y'all for today, okay? And plus, I got a few weeks like this that are what I call slow weeks. That way people that are behind on homework can start sort of catching them up. Most of y'all in here are pretty good, I think, though, right?
I didn't do my last 3 because I thought it was pushed back, but I'll still ask you when you're through after school.
Yeah, you won't be bad off him. All right, so the 8A support. The population of a town is increasing by 635 people per year. Is that linear or exponential?
Yeah.
Linear because they're not giving me percent, right?
Yeah.
So this would be linear growth. Because every year is going to be going up by 635. Okay? Now, if the population today is 1,900, what will it be in 4 years? And I'll even tell you that 8A homework goes over questions just like these when they're doing in support. So, I know I got 1,900 people now. You know, I'm going to increase it, what they say, 635 per year. And I'm going to do this for 4 years. So 635, 4 times. And with linear, you're just adding them on, okay? So you had 1,900. When you added 635, that puts you at 2,300 and something here. Plus 635, puts me at 30,000. Plus 635, puts me about 3,800. And then plus that last 635, I'm getting 4,440 people. Right? So linear, we basically add each year's amount on and move on, okay? Now you could have done this 1,900 plus 4 times 635. You could have shortcut that any way you wanted to, okay? As long as you're doing basically the same operations. All right, let me see what this, number 2. All right, so this one says, y'all, during the worst periods of hyperinflation in a certain country, the price of food increased at a rate of 15% per month. So increased 15% per month. So I guess hyperinflation means stuff goes up really high, right? Is that linear or exponential?
Exponential.
Exponential, because now you're looking at percents. Remember, percents don't mean it's not gonna increase the same amount every year, but the same percent. So now, if your food bill was 120, if food bill was $120, what was it 3 months later? And I'm gonna show you on this one. It's a little bit more tedious process to find these amounts, okay? Because it's not going up the same amount every year. So we're doing this for 3 months. We're starting with $120. What was my percent they said to go by? 15. So that'd be like multiplying by a 0.15, right? So let's see what is 15% of 120. I'm getting $18. But to find the total after that first month, I take the 120 and add the 18. So 120 plus that 18 gives me $138. And that's just after 1 month, your bill went from 120 to 138. So now for the second month, we're starting with 138. Right? What is 15% of 138? I'm ending up with a 20.7.
So you added it on there.
Huh?
You added it on there.
This 20.7?
Yeah.
So what I did is I took the 138,
Okay.
multiplied by 0.15, and that gave me 20.7. Now I'm going to take this 138 plus my 20.7. So see what I'm doing? I started with 120. After I added my 15%, I was at 138. I started with 138. After I added my 15%, I'm at what? So add that to what? 138. So now I'm at 158.7.
You wouldn't round that?
Oh, not rounding yet. Now at the end, it might say,
I'm trying to work that.
at the end, I'm going to round it to the nearest dollar, okay?
Okay.
So now you're starting with the 158.70 times 15%. But look, the first year 15% was 18. Second year 15% was 20.7. Let's see what it is that third year. 158.7 times 0.15 will give you 23.805. So add that to the 158.7. So 158.7 plus what I just got, 23.805. So I'm ending up with a 182.505. If I round that to the nearest dollar, I'm gonna make that a 183. In 3 months. So my deal is going to go from 120 to 183, which is an increase of $63 from hyperinflation, okay?
Do I have to round this?
Oh, no, I wouldn't round it to my last one. So yours is one of the nearest dollar, so yours will be 138. Yeah. See? Now, some of them will say nearest dollar, which will be no decimals, and then some might say nearest cents, which will be 2 decimal places.
I have a question.
Mhm.
So did you do it 3 times for the 3 months?
Uh-huh.
Okay.
Because here was my starting amount for month 1, and after 1 month, it went up to 138.
Okay.
Then 138 was my starting amount for the second month. After I did all my increases, I went up to the 157. Now, if I had another month, I'd brought my 183 down here and started all again, okay? But I wanted y'all to notice one thing. The linear went up by the same exact amount every year. This is not the same absolute amount, but it's the same relative amount because it's 15% a year, okay? All right, so let's see what this street is. The price of a computer component is decreasing at a rate of 15% a year. Would that be a decrease linear or exponential?
Exponential.
Exponential. So then they say if it costs $50 today, whoops, if it costs $50 today, what would it cost in 3 years? Now, y'all, I want y'all to notice the main difference here. Over here, it was increasing 15% a month. This is decreasing that 15%.
So I have to try.
So right here, we're going to subtract instead of doing the adding. Good job. Now, so let me show you what I'm going to do. I'm going to start with $50. And multiply that by 15%. That's going to give me the amount of the decrease. So let's see. 50 times 0.15 gives me 7.5. But y'all remember, we're not going to add this time. We're going to take the 50 minus the 7.5 to get my total after 1 year. So 50 minus 7.5 will give me 42.5. So the main thing I would remember is that you subtract for decrease. So we're over there, we was actually adding for our increases, okay? So now, guess what? Starting year 2, you're now at $42 and basically 50 cents. You're decreasing another 15% this year. So 42.5 times 0.15. Now I'm expecting this to get smaller and smaller because I'm getting smaller amounts here each time, okay? So this was 6.375. So it was decreasing, that's about 750, now it's decreasing about 637 or so, 638. So now we take this 42.5 we started with, subtract my decrease of 6.375, and this will now give me the ending amount for that part after the second year of decreasing. So doing that, my part is now down to 36.125. Now, y'all, I'm just leaving all my decimal points until I get to the end, and then when they tell me where to round it, I'll round it to the nearest dollars or cents, okay? And this one will round to the nearest cents when we're done. All right, so year 3, my starting amount is $36 and basically 13 cents, it looks like. I'm decreasing by another 15%, which now gives me 5.41875. So now I will subtract that decreased amount from my starting amount for third year, minus the 5.41875. This answer now I will round off, okay? So 36.125 minus 5.41875. I ended up with 30.706. So I'm going to call that 30.71. So if you decrease by 15% a year and you started at a $50 part, after 3 years, it's now worth $30. Okay. I don't know if y'all have ever seen stuff on taxes like amortization and depreciation and stuff. None of us probably got that kind of assets, but still they look at their assets and they depreciate and more than times, whatever that word is, like we're doing sort of. I never get to do that kind of fun stuff though, right?
My Beanie Baby collection, appreciate it.
There you go. And you'd have thought they'd have went up, right?
That's crazy.
They went, for a while, that was the big thing back in the day,
Sure thing,
you know? Are they all packaged still? Who was that? That was Walmart. I mean, not Walmart, but well, the McDonald's used to give away a lot of Beanie Babies too. Happy Meals and stuff, remember? It must have been back in the 90s. Someone went up. What's that Beanie Babies? All right. The value of a house is increasing by $2,000 a year. Linear or exponential?
Linear.
Linear, because now we got a certain amount every year, so this is definitely linear. So if this house is 180,000 today, what will it be worth in 5 years? And I'll tell you, when you're figuring out amounts, it's a lot nicer on the linear than it is with the exponential, because you don't have to figure out all these 15% and stuff. You just got to keep adding the same amount every year. So I'm going to start out with 180,000. And I'm going to add $2,000 a year times 5 years. So I wanted to show y'all both ways. A while ago, I wrote out 2,005 times, but this time I'm going to multiply the shorthand that. How about that? So I'm going to have 180,000 plus basically, what is that, 10,000? So after 5 years, if this house goes up $2,000 a year, it'll be worth 190,000. Okay, so that was my goal today, to get y'all to see the difference between exponential and linear, okay? So if you got support, that's gonna take care of your support for you, those 4 questions. We'll come in Thursday and do 8A MR part, okay? They'll be doing basically the same stuff, so y'all be happy. That's all it's doing, you know, linear growth. And now, you know, the MR part might jack it up just a little bit and make it crazier for us, but it's gonna be about the same stuff, okay? Actually, I can look and see real quick. I got that. I didn't bring the notes, so this. Yeah, not much left on that, so we'll knock out 8A Thursday. It'll probably be another easy day because there's not a lot of material in 8A going through. That way, I'm trying to get y'all caught up and everything for this class is over, because we're down to about a month. You're all gonna be sad, right?
Sorry for it.
Saturday's not over, we got 2 more, we got 3 more years.
Any of y'all going summers?
I am.
So you said you was gonna try to, are you?
For summer.
Get out of here quicker, girl. That's the way to do it, right?
Yeah.
Can you, I got a friend